Welcome, Mr. Sutton here with the AB Calculus 310 Extra Practice Number 2 solutions on derivatives of exponential functions. On this problem, we have a non-e base, so we're going to have to use the non-e base rule. That's going to be b to the x times ln of x. So that would be 8 to the x times ln of 8, and there's our derivative. To find this derivative, at first glance, this looks like it's going to be a quotient rule. But if you look closely, we have the same base, so we could actually use our exponent rules to simplify this before we take the derivative and completely avoid the quotient rule. So converting this to just 1e to a power, we can subtract the exponents. This is going to be e to the 5x cubed minus 2x squared plus 5 if we subtract both of those exponential terms. And now we just have a chain rule. So a derivative of e to the something is going to be e to the something times the derivative of the something. So that's going to be 15x squared minus 4x in a parentheses here. And that's done. To take the derivative of this exponential function, we need to apply the chain rule. So my outer function, we've got e to the something. Derivative of that is just going to be e to the something, so e to the 4x squared, times the derivative of 4x squared, which is 8x. To take the derivative of this function, we're just going to use the chain rule. I have the derivative of e to the something, which is e to the negative x over 4, so that's the outer derivative. And we'll just multiply by the derivative of negative x over 4, which is negative 1/4. To take the derivative of this function, we're going to apply the chain rule. So I have 10 to the something as the outer function. Derivative of that is going to be 10 to the something, 10 to the 5x to the 5th, times the ln of the base, ln of 10. So that's just the outer derivative, that whole thing. And now we have to take the derivative of the 5x to the 5th. That's going to be 25x to the 4th. To find the derivative of cosine of e to the x, we need to use the chain rule. So the outer function is cosine. Derivative of cosine of something is going to be negative sine of something. In this case, negative sine of e to the x. Now we have to multiply by the derivative of e to the x, which is also e to the x. To find the derivative of this function, we're going to have to use the product rule, u prime v plus uv prime. Setting up a box and ribbon for that, we have our two factors, 7 to the 5x squared, and our other one is going to be 7x to the 10th plus 8 over here. Now we take their derivatives. This is 7 to the something. This is a chain rule here. So the derivative of that, the outer derivative, would be 7 to the something times ln of 7. So 7 to the 5x squared times ln of 7. And we have to multiply by the derivative of 5x squared, which is 10x. Over here, derivative of 7x to the 10th is 70x to the 9th, and the 8 is differentiated away. That's just 0 there. So now, using my ribbon to put it all together, I've got all this stuff down here times parentheses 7x to the 10th plus 8, plus we've got 7 to the 5x squared times 70x to the 9th. And that's actually a plus there. There we go. Now we're good. For this problem, taking this derivative, I'm going to use the product rule. So I've got my box and ribbon here. X squared and e to the x squared are our two factors. Derivative of x squared is 2x. E to the x, that's a chain rule. We have e to the something, so e to the x squared times the derivative of x squared, which is 2x. Using the ribbon to put it all together, we've got 2x e to the x squared plus x squared times 2x e to the x squared. So I guess you could combine that to get 2x cubed, or you could leave it unsimplified, either way. To figure out this derivative, I need to use the chain rule. My outer function is 3 to the something. Derivative of that's going to be 3 to the something times ln of 3, so 3 to the tan of 2x times ln of 3. Next function in is the tan function. We have tan of something. Derivative of that is secant squared of the something, the 2x. And finally, we multiply by the derivative of 2x, which is just 2. For this problem, we're trying to find the derivative of x to the 1 minus e. Now, although this is in an extra practice on derivatives of exponential functions, this is not actually an exponential function. The variable, the x, is in the base, not the exponent. So for that reason, we have to use the power rule instead. So this is going to be our power rule, means we're going to multiply the derivative out here. So this is going to be 1 minus e in the parentheses times x to the whatever this is when you subtract 1. So that would be negative e. For this problem, we want the derivative of 2e to the x. Well, e to the x is its own derivative, and 2 is just along for the ride, so this is just 2e to the x for the derivative.